When installing a square D 200 amps panel and using underground service entrance cable, it's important to consider National Electrical Code requirements and the panel's listing. The National Electrical Code Section 310.13b4 states that underground feeder and branch circuit conductors shall be buried at least 24 inches deep. The National Electrical Code Section 310.15b7 states that underground feeder and branch circuit conductors shall be permitted to be installed in raceways. The National Electrical Code Section 310.15b8 states that underground feeder and branch circuit conductors shall be type UF, use, type USM-2, or other identified for direct burial. If the square D panel label does not specifically include use-rated cable, it means that the panel has not been tested and certified for use with use cable. For the installation, according to the National Electrical Code requirements, use cable must be used for the load wire going back into the ground. However, since the panel label does not specifically allow for use cable, there are a few options to consider. Firstly, verify with the manufacturer if the panel is compatible with use cable. Secondly, install the use cable in an approved raceway, such as conduit or cable tray, before connecting it to the panel. This will act as a certified means of entry for the cable. Thirdly, if square D does not approve the use of use cable with the specific panel, you may need to consider selecting a different panel that is certified for use-rated cable. It is always recommended to follow the manufacturer's instructions and consult the electrical inspector for guidance. In this case, verifying with square D and/or the electrical inspector will ensure a safe and code-compliant installation. To elaborate further, let's delve into the specifics of use cable and its applications. Use cable, or underground service entrance cable, is designed for direct burial in the earth, providing a durable and moisture-resistant solution for bringing power from the utility source, such as a meter pan, to a building's electrical panel. Its construction typically involves stranded aluminum or copper conductors insulated with a moisture-resistant cross-linked polyethylene XLP or similar compound, which is then encased in a tough outer jacket. This design allows use cable to withstand the harsh conditions of direct burial, including exposure to moisture, soil chemicals, and physical stress. Now, let's consider the implications of using use cable with a square D panel that doesn't explicitly list use cable as an approved conductor type on its label. The panel's label serves as a certification of the types of cables and conductors that have been tested and approved for use with its specific panel. When a panel hasn't been tested with use cable, it doesn't necessarily mean that use cable cannot be used, but it does require additional verification and precautions. One of the primary concerns is the compatibility of the cable's insulation with the panel's terminals and components. Different insulation materials can react differently to the environmental conditions within the panel, potentially leading to corrosion, degradation, or even electrical faults over time. Therefore, it's crucial to ensure that the use cable's insulation is compatible with the materials used in the panel's construction. Another consideration is the ampacity, or current carrying capacity, of the use cable and the panel's main breaker and branch circuit breakers. The cable must be sized appropriately to handle the expected load without overheating, and the panel's breakers must be rated to protect the cable from overcurrents. These ratings are typically specified in the panel's label and in the cable specifications. When using use cable in a situation where the panel label doesn't explicitly approve it, consulting with square D, the panel manufacturer, is essential. They can provide specific guidance on whether the panel is compatible with use cable, taking into account the cable's insulation type, ampacity, and other relevant factors. Square D may have internal testing data or application notes that address this specific scenario. If square D approves the use of use cable with a panel, they may provide specific instructions or recommendations for installation, such as using a particular type of connector or applying a sealant to protect the connection from moisture. If square D doesn't approve the direct connection of use cable to the panel, an alternative approach is to use a raceway to transition from the use cable to a different type of conductor that is approved for use with the panel. A raceway is an enclosed channel designed to hold and protect electrical wires and cables. Common types of raceways include rigid metal conduit (RMC), intermediate metal conduit (IMC), electrical metallic tubing (EMT), and rigid polyvinyl chloride conduit (PVC). When using a raceway, the use cable would be run from the meter pan to a junction box located near the panel. Inside the junction box, the use cable would be connected to individual conductors such as THHN or XHHW wire, which are approved for use within the panel. These individual conductors would then be run through the raceway and into the panel, where they would be connected to the main breaker or branch circuit breakers. This approach provides a physical barrier between the use cable and the panel, ensuring that the cable's insulation doesn't directly contact the panel's components. It also allows for the use of conductors that are specifically approved for use with the panel, ensuring compatibility and compliance with the panel's listing. When selecting a raceway, it's important to choose one that is appropriate for the environment and the type of conductors being used. For underground applications, rigid metal conduit or PVC conduit are commonly used due to their durability and resistance to moisture and corrosion. The raceway must also be sized appropriately to accommodate the number and size of conductors being installed. The National Electrical Code provides detailed guidelines on raceway sizing and installation. In addition to consulting with Square D and considering the use of a raceway, it's also essential to consult with the local electrical inspector. The electrical inspector is responsible for ensuring that all electrical installations comply with the National Electrical Code and local electrical codes. They can provide valuable guidance on the proper installation of use cable and the selection of appropriate materials and methods. The electrical inspector may also require additional inspections or testing to ensure that the installation is safe and compliant. When installing use cable, it's important to follow all applicable safety precautions. Before working on any electrical equipment, always disconnect the power at the source. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Use properly insulated tools. Never work on electrical equipment in wet or damp conditions. If you're not comfortable working with electricity, it's best to hire a qualified electrician. In summary, when installing a Square D panel and using a use cable, it's crucial to consider the panel's listing, the National Electrical Code requirements, and the recommendations of the panel manufacturer and the local electrical inspector. If the panel label doesn't explicitly approve the use of use cable, explore alternative solutions, such as using a raceway to transition to approved conductors or selecting a different panel that is certified for use with use cable. By following these guidelines, you can ensure a safe and code-compliant installation. Furthermore, let's discuss the specific National Electrical Code sections mentioned earlier in greater detail. National Electrical Code Section 310.15b4 addresses the minimum burial depth for underground conductors. This requirement is in place to protect the conductors from physical damage, such as being struck by digging equipment or being crushed by heavy loads. The 24-inch minimum burial depth is a general requirement, but it may vary depending on the specific application and local codes. For example, if the conductors are installed under a concrete slab or in an area subject to heavy traffic, a greater burial depth may be required. National Electrical Code Section 310.15b7 permits the installation of underground conductors in raceways. This option provides additional protection for the conductors and allows for easier access for maintenance and repairs. When conductors are installed in raceways, the minimum burial depth may be reduced in some cases, as the raceway provides a degree of physical protection. However, it's important to consult with the local electrical inspector to determine the specific requirements for raceway installations in your area. National Electrical Code Section 310.15b specifies the types of cables that are approved for direct burial. Type UF cable, or underground feeder cable, is a common choice for direct burial applications. It's similar to use cable, but it's typically rated for lower voltages. Type US M-2 cable is an upgraded version of use cable that is rated for higher temperatures and is suitable for use in more demanding applications. The National Electrical Code also allows for the use of other cables that are identified for direct burial, as long as they meet the applicable requirements for moisture resistance, physical protection, and ampacity. When selecting a cable for direct burial, it's important to consider the specific conditions of the installation, such as the soil type, the moisture content, and the expected load. Choose a cable that is rated for the appropriate voltage, temperature, and environmental conditions. In addition to the National Electrical Code, local electrical codes may also have specific requirements for underground installations. These requirements may vary depending on the jurisdiction, so it's important to consult with the local electrical inspector to ensure compliance. Local codes may address issues such as the type of backfill material that can be used, the spacing between conductors, and the requirements for grounding and bonding. Grounding and bonding are essential for ensuring electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and de-energize the circuit. Bonding connects all metallic parts of the electrical system together, creating a low impedance path for fault current. The National Electrical Code provides detailed requirements for grounding and bonding, and it's important to follow these requirements carefully to ensure a safe and reliable electrical system. In the context of the question, the concern is the compatibility of use cable with a specific square D panel. It's crucial to emphasize that electrical panels are designed and tested to work with specific types of conductors and connections. Using a conductor that isn't approved for use with the panel can create safety hazards and potentially void the panel's warranty. Therefore, it's always best to err on the side of caution and follow the manufacturer's recommendations. If the square D panel label doesn't explicitly list use cable as an approved conductor type, the safest course of action is to contact square D directly and ask for clarification. They can provide specific guidance on whether the panel is compatible with use cable and, if so, what precautions need to be taken. If square D doesn't approve the use of use cable with the panel, the alternative options, such as using a raceway to transition to approved conductors or selecting a different panel, should be considered. When using a raceway, it's important to ensure that the raceway is properly sized and installed. The raceway should be large enough to accommodate the conductors without overcrowding, and it should be securely fastened to the panel and the surrounding structure. The conductors should be properly supported within the raceway, and the raceway should be sealed to prevent moisture from entering. Selecting a different panel that is certified for use with use cable is another viable option. This approach eliminates the compatibility concerns and ensures that the installation complies with the manufacturer's recommendations. When selecting a new panel, be sure to choose one that is appropriately sized for the load and that meets all applicable codes and standards. In conclusion, when dealing with electrical installations, it's always important to prioritize safety and compliance. Follow the manufacturer's recommendations, consult with a local electrical inspector, and adhere to all applicable codes and standards. By taking these precautions, you can ensure a safe and reliable electrical system.